the real number sets, we are given the following relation through a property, through the statement of a property, which is x relates y if and only if x squared equals y squared. And we are given another set. And what they want us to compute this set, the set of equivalent, the quotient set, in a nutshell. So, well, as I said in the last class, I'm going to take the first element here and see what elements are related to that one. In other words, I'm going to compute that class. So what elements are related with -3? I'll write this so that there is no confusion here. What elements are related to -3? So I have to apply this properly here. Yes, square. So -3 squared is +9, right? And +3 squared is +9. And I see it is the only one holding that property. So here I have -3 and +3. Obviously, -3 is related to itself because it is equivalent relation. So far so good. I can say -3. Then I won't use that one, right? In the future. So I just curve this out. Then I have -2. -2 related x. Well, the same thing, -2 is related to -2. That's obvious, nothing to say. And the square of -2 is 4, as the square of 2 is 4 too. So the same thing here. Well, I'm skipping this, but it's very clear that the equivalence class of -1 is formed by elements -1 and 1. And finally, what's the equivalence class of 0? Just 0. Just a single zero. Okay, so these sets here, these here, 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 and here, they form a partition of A. Let's call this set C1, for example, C2, C3, and C4. So the union of all elements of the partition is A. And no two elements share a common element. Share. I don't know if Yes, please.
Why partition of A and not partition of B?
Did you miss yesterday's class?
No.
Yeah, that's why. Because yesterday I explained the relation between, I defined what a partition is, and I explained the relation between equivalence, relations, and partitions. So just check that we have like this. Anything there. Okay. Do you find this very hard? It's a small exam question. The other thing, I mean, that was like an appetizer. It's just for you to start to answer the big question, which is here B. And now I want to compute the quotient set of R under this relation here. So I'm going to say something because I feel generous today. Okay, 0. That's there. And it is formed by just one element because 0 squared is 0. So what other elements should I add here? So I did this little example here with the integer numbers. In general, for real number, what do I have? What elements are related by this relation? Yes, very nice. So zero is excluded because you write that down and you get all the points. Okay, good. Good. Okay, I'm leaving 20 and 21 for you. For the student. And I'm going to do 22, which is also an examination question. So here you have the very well known Z7. Yes.
Could you explain again how you do that, the quotient?
The quotient set? Yeah, the quotient set. Okay, I'm going to erase this. So for the quotient set, you take an element, right, and see and you ask what the element such that A is related to X. Right. So here, well, 0 is clear. 0 is related to itself and that's it. Right? From the previous example, I'm seeing that if I have a number only minus that number is related to the first number. I mean, if I have A, the only element related to A is minus A.
By that, because
the square will cancel out the signs and will give the same square, right?
so in this case, A related to minus A
Because A squared equals minus A squared. Right? So I'm coming back to this one, Z7. So here. by those classes, right? Those classes, here the numbers are between 0 and 6. They are called canonical representatives. And I recall what a canonical representative was. When you say the class of 0, you may write the class of 7 also. They have the same elements. Or you may say the class of 14, but what you do is just take the smallest one. And that one is called the canonical representative. Okay. So here, it must be a test question, otherwise I don't get it. It's so easy. You are given a bunch of classes. Bunch. That's a very colloquial expression. Bunch. And you are asked to determine whether this set is Z7 and describe it here. So what's the canonical representative for -11? 3. Because -11 minus 3 is -14, which is a multiple of 7. Right. -6.
1.
Okay, you can take. Yes. And the answer is
4.
no. What's missing here? That's it. Right. Here I don't see the class of 6. So that's it. That was that's very, very good. I feel if it didn't easy for you,
So they belong to C7, no?
yeah. See, I'm asking if this set equals this set. They have to have the same elements. And they don't, because here I have the class of 6. Where is the class of 6 here?
They have to have
Yeah, the
all
question-
the elements.
Yeah. The question is whether these two sets are equal or not. And they are not, because 6 is missing here.
If, for example, you have the 6, but the 2 there is repeat.
Repeating. Oh, that's a very nice question. Does it matter? The first definition I gave was the definition of set. If you haven't memorized it yet, you are not doing well. Set. What's a set?
An ordered collection of
An unordered collection. Does it matter if you repeat the elements? Not at all. You don't, usually when you write down a set, you don't repeat elements. But if you do, it doesn't matter. It is the same set. Right? So here, we have these 2 and 2 repeated. But it counts as the same element. Because we care about the elements, not about the repetitions or the order.
So if in that set,
If I substitute this by 6, then the answer will be yes.
no, if there was another number equal to 6,
Yeah. Then the answer will be yes. Yeah. Thank you for your was. It was very nice. Okay, what else? Another exam question. So we are considering Z6, sorry. And And here I have an infinite set, which is the set of the powers of 5 modulo 6. And they are asking me about this membership test. So I'm going to obtain some of those elements here and see what happens to get a pattern, right? So this set for n equals 0, what do I get?
1.
Yes. Then I will get 5.
20.
Then I will get 25, which modulo 6 is 1. Do I have to hold? Do I have to carry on?
No.
May I stop?
Repeats.
Yeah, it repeats itself. So the answer is
No.
so this is just 1, 5. Bear in mind that those sets are infinite sets, right? This is 1 plus all multiples of 5, and this is 1 plus all multiples of 6, and this is 5 plus all multiples of 6 too. Different from the class of 3, right? I think it was easy. Just a question of strategy. Okay, let's move on. Yeah. You know move on? Let's go to partial orderings and posets. So as I said, the case diagram is very important. You will get a question in the exam. I'll take care of it. Believe me. So I'm considering this poset natural numbers. Oh, sorry. With the divisibility. And I'm given 4 sets, and I have to determine the case diagram and all the notable elements, namely, you know, namely, as a ver, is when you are going to make an enumeration, you make it many times to call attention on the list. So, namely, maximum element, minimum element, maximum element, and minimum element. So first, two, 3, 4, 6, 9, 12, 18, 24. So I recall what a Hayes diagram was. I just draw the normal cycle diagram. I remove loops. I remove all edges produced by applying the transitivity property, and then I arrange the resulting graph so that the terminal vertices are upwards, around here, and the initial vertices are below, right? So I have to read my graph bottom up. Yeah, here it is. In English, this expression is quite strange. You say bottom up, how do you say the other way?
Up, down.
Yeah, you don't say up, bottom, you say top, down. That's the way it is. No, there's nothing to say, just memorize that. So bottom up, but top, down.
And up, down. You can also say up, down.
Up, dimensional analysis.
It is also correct to say.
Yeah, sometimes it is correct, right? No problem, people will understand, but it's not idiomatic, it's not the way people talk. So that's another high level when you talk as people talk. First, you make yourself understood, and then you immerse in the language. That takes years of practice. The sooner you start practicing, the better. So here I have 2, 3, maybe around the basic around out of the space. So 2, 3, 4, 6, 9, 12. Okay. Sometimes you have to move some numbers in order to make a nice, neat drawing. Any questions here?
Why do you write?
That way? Because I want to compute, to draw the H diagram. So the H diagram puts the minimal elements below and the maximal elements above. So 2 divides 4, correct? 4 divides 12, but I don't draw this arrow here because it is a triangle and it doesn't appear on the H diagram. And then I draw this one. Right? Do I have to draw the arrow between 2 and 24? Why?
Because you went to 24 through 4 and 12.
Okay. Just one. Alejandro, you have an idea, I think.
Because you go to 24 through 4 or to 12 to 24.
Okay. So even though I erased that one, this cares to delete that one. Right? So that's correct. Then I have 3, 6, 3, 9. I don't draw that one. Do I have to draw this one? Yes. Because it is not part of any triangle. But I don't have to draw that one, right? Because that will form the triangle. Right? Oh, sorry. Yeah, that was wrong. Sorry about that. Okay, what else? What else do I have to add? Yeah. Yes.
2 to
By
6.
the way, when you speak, forget to say else many times. When you are referring to two groups, the second must have the word else. So when I say what else, que más, what else? So you said, sorry, I have to add
2 to 6.
2.
2 to 6.
Good.
6 to 29 to 18.
6 to 24.
9 to 18.
Because, okay, I didn't draw that one, right? But I have it. So here there is a triangle, so I shouldn't.
And if you go from 2 to 18?
To what?
2 to 18.
To 18.
You're not 3? Or a triangle.
Do I have to draw that one? Yes. You don't know, I'm asking.
I think yes, because you are not forming a triangle.
Or you don't think, you don't say, I think that I should, or I have to, you have to use your attention. So, yeah, when I drew the numbers, I did it in a random way, right? Because at the beginning I didn't know what the best arrangement was. So this is a little bit messy here. When you give the final answer, it's better to write it on pencil and then draw a nice final version. So you are saying that I have to add from 2 to 18. Who votes for that? Nobody. So why shouldn't I to draw that? Yes, Adrian?
Because we can go through 6.
I can go from 2 to 6,
6 to 3.
but I mean the drawing is a kind of a mess, but I certainly can go to here and then
15.
To 18.
From 6 to 3.
yeah, I could go from 18 going.
Es que
No,
falta una línea del 6 al 18, ¿no?
6 to 18.
6 to 18. Falta una línea.
Okay. Now we're okay.
But if you erase 1 arrow from 6 to 18 and you go directly from 2 to 18?
No, porque es lo mismo que de 2.
No, because you have to respect the transitive property. So in the Hayes diagram, right, loops
Sí,
are
porque
removed.
sería la misma línea. Pero como llegas a 4 al 18, por eso.
Transitive arrows are removed, and that means you have A to B, B to C, and A to C, and that's deleted. Right? So if I have from 2 to 6 and 6 to 18, then I cannot draw that. Right? Okay. Yes.
Why did you write the arrow from 3 to 12? You should write the arrow from 6 to 12 and erase that one between 3 and 12. 3 goes to 6, then 6 to 12. So 3 is related to 12.
So I'm drawing this upwards. So this element is below, in the sense of the order, below 6 and is below 12.
12 or 12 to 6.
So
Six to
the arrow 6 to 24.
Oh, pero vamos a
Okay,
calmar.
okay. Relax. Relax. So, yeah, the problem is not actually. So that's clear. That's clear. There's nothing in between. That's clear. So I have that one. Okay, that's clear. That's clear. Then I have that one, which is clear. I cannot have. Okay, and I erase this one, right?
You have 6 to 12.
Yes. I have 6 to 12. Because this is a quadrilateral and I'm removing two triangles here, so that's correct.
6 to 18.
6
6 to 18.
9
6 to 18.
6
And
9
9
to 18.
and now, if you don't mind, I'm going to write 18 here for clarity of drawing. Okay, so yeah, this guy should be here. There was kind of a mess, and that line should be there. Okay, great. 1, 2, 3, 4. This is a quadrilateral, but it doesn't look like what it is. That was it. Yeah. Okay, so now maximal elements. Maximal elements are. I think this is a nice drawing, and you can.
18 and 24.
Yes. Who are the guys not having anybody else above 18 and 24? Right? Minimal elements 2 and 3. Maximum
None.
9. Right? And yes, more here.
But the maximal elements depend on how you draw. Like, no?
No, I mean, no. No, that's very incorrect. Maximal element, I mean, this is just a help to visualize the structure of the relation, right? The definition of a maximal element is B is a maximal element if there is no A such that B is less or equal than A. In this case, this is general notation, right? In this set such that 18 divides that element or 24 divides that element. I mean, the idea, as I said, is to draw it upwards. So you write
Okay, I understand.
the list elements here and you go step by step. Well, if I could do it like that, right? 24 and write it here. But still, those arrows who are pointing upwards will give me the same thing: 2, 4, 12, and 24. Which means those guys are less than 24 here, right? Yeah, but be careful with that. Don't get confused by the drawing. The drawing is supposed to show the structure of the relation and also how structured is your mind. Okay, so
One question.
yes, please. I forgot your question. Sorry about that.
Can you go to a number bajando de número? Es decir, tú vas
No,
de 2
no,
al 6, puedes
no.
bajar al 3 y ir al 1.
No, you can't. You can't. Because the idea here is, well, initially on the cycle diagram you have arrows. Yeah. The last step for constructing the case diagram was remove the arrow as long as you draw things bottom up. Right? So you start on the lowest element in the graph and you go upward. It is not valid to go 6 and then 3 because 6 doesn't divide 3.
And then, how do you arrive from 2 to 9?
You don't go to 9. You can't. You can't. You go to 2 to 6, but you are not allowed to do that because you go downwards. And that's forbidden,
You
right?
have always
To go upwards. It was the third case diagram's condition. Constraint. So finally I'm going to do.
One question.
Yeah, sure.
If you erase the arrow to 6 to 12 and you write 6 to 24, you can make it
No, because it will be part of a triangle.
triangle.
Sí.
Triangle.
Where? Is it triangle?
Si tú borras la
I go from 6 to 12 to 12 to 24. I can't have that arrow here.
No, but
No, but you erase
6 to 12.
yes.
Well, I can't because it is part of the relation. 6 divides 12. I cannot. In another different relation, suppose it is not divisibility. Okay, then if I don't have that, I should have that. Right, but then it would be a different. Just respect what the relation said. Well, I think this is that's another exam question, and I think I said it. I believe so. So here, well, you have that infinite set, which is 1, 2, 4, 8, etc. So here I have 1, and I have 2. I have 4, I have 8, right? Then I have 3, and I have 6. This is infinite. Well, it's clear that the Higgs diagram is that, right? That's very easy. There are no arrows crossing from this branch to this branch. Ramas, cruzados, anything. Branch. So, first question, maximal elements. minimum elements. And here comes the catch. People think because you have a unique maximum element, it is the maximum.
No, the maximum is 8.
There's no maximum here. No. So when the maximum exists, right, is unique. But you may have a unique maximum element and still you don't have a maximum. Because this branch is infinite and you have another number that is bigger than the previous one. Yeah. The problem is that for maximum,
and in that one,
you must require for all A, in capital A, has to be comparable. And what happens here is these guys here are not comparable. Right? So what are the minimum? One divides everybody is related to 1, right? Oh, by the way, here we have a few magic numbers. Don't you see them? No? 3, 6, 1, and 4 are very famous magic numbers. No? You don't know that? Sure.
you said
What do you see here?
2.
3. What do you see here? 6. What do you see here? What do you see here? 3, 6, 1, 4. Those numbers. Yeah, I told you. They're magic. Okay, let's talk about magic then. What's wrong with you guys and
No,
the-
one question. One question. Why? You said there.
How did I do that?
No.
Oh, okay.
After you tell me.
No, yes. You see?
Question. There, you said there is no maximum elements because the arrows continue to the
Infinity, yeah.
And in there, that arrows doesn't continue.
Yeah, but
But
okay.
there is no number which bigger than anyone that divides all.
Yeah.
And no
It's divided by
Yeah, graphically, be quiet, just a little bit, guys. Graphically, for the maximum to be there, you have to have like that. Everybody has to end at that point. Here you don't have that. And here, you have an infinite branch, so no way. Right. Okay, so